Let us look at the revision tutorial A that you did during the school vacation. Revision tutorial A on vectors that you did during the school holidays in May. Let's look at the first question, number 1. In number 1, you are told about two vectors A and B. They are non-zero and non-parallel. So potentially the two vectors A and B look like this. So you have two vectors which are non-zero and non-parallel, and you're given some condition about the vector A and B in the form of equation that 3a plus t of a minus 2b is equals to minus a plus 2b plus s of a minus b. Right, given this condition. So what we're going to do right now is we are going to actually do some form of expansion. Let me just be sure that I've copied correctly the question. Right, so I'm going to group the A's together. This gives me 3 plus Ta minus 2T of B. Then this gives me minus 1 plus S of A plus 2 minus S of B. I want you to know that if two vectors are non-parallel like this, and then a multiple of A plus a multiple of B is equals to a multiple of A and a multiple of B, a property of non-parallel vectors is that you can simply compare the coefficients. This is only true if the two vectors A and B are non-parallel. That you can just compare the coefficients on both sides. So what you have here is that 3 plus t is equals to minus 1 plus s, or you can say that t plus or t minus s rather is equals to minus 4. This is your equation 1. And then what you have is minus 2t plus s is equals to 2. Right? I'm simply comparing the coefficients of A and B. So if you were to solve them simultaneously, you will get t equals to 2, and then your s is equals to 6. This is how you can solve question number 1. Right. Then in question number 2, what do we have in question number 2? In question number 2, you're asked to find the magnitude of the following vectors. So for the first vector, part A, the magnitude of the first vector 3, 4, 0. Imagine that this is a 3-dimensional space. To find the magnitude of 3, 4, 0, to find the magnitude of vector is like this: 3 square plus 4 square plus 0 square, and this gives you a value of 5. And then it also asks you to write down the vector of magnitude 260, same direction as 3, 4, 0. You want a vector, so let this vector be V. You want this vector to be in the same direction, so V must be a multiple of 3, 4, 0. And to be in the same direction, this multiple has to be a positive multiple. But if you have a positive multiple of another vector, not only are you parallel, sorry, not only are you parallel, you're also in the same direction. Right, so now to find a vector in the same direction as 3, 4, 0 and having a matrix of 2, 60. This vector already has a magnitude of 5. So what do you think that k ought to be? So in order to have a magnitude of 260, right? The value of k will have to be 260 divided by 5. And it has to be 52. So therefore the intended vector v is equals to 1, 5, 6 and 208 0. So this is how you get the first vector for part A. And for part B, you're asked to find the magnitude of this vector. Imagining that this is again 3-dimensional. You just find the square root of this 5 square plus minus 12 square plus 0 square, and this gives you a value of 13. Right? Then to find a vector in the same direction as this, going by the same calculation as before, what you need is the vector that you need for this case will be 20 times this vector 5 minus 12. Because this already has a magnitude of 13, to have a magnitude of 260, right? You need 20 in front. So then this gives you 100 and minus 240, 0. And this is your question 1 and 2. Okay, do you have any question to raise? You can just stop me. Let's into question number 3. For question number 3, you are given that a vector pi plus qj is parallel to another vector. So if these two vectors are parallel, so if I may, I just imagine it's 3-dimensional, so it's p, q, and 0. Because it is parallel to the other vector, so it's a multiple of this other vector 1, 2, 0. So by comparison, I can then say that p is equals to k, q is equals to 2k, therefore q is equals to 2p. And then you're told that the magnitude of this vector is 5. So this is maybe let's call this equation 1. And now you're told that the magnitude of this vector is 5. So the magnitude of this vector you're told is 5. Right? So you can form a second equation using what you've understood about magnitude. So you can say that p square plus q square is equals to 5 square. Right. Then you can solve them simultaneously. If you solve them simultaneously, what you're going to get is so let's find p again. Let's find p. What you can do is you plug this thing inside here. You will get p square is equals to let me see here, is equals to 5, right? Equals to 5. So therefore, P is equals to, they want a positive value of P. So it's just root of 5. Okay, that is question number 3. Then we have question number 4. In question number 4, what do we have here? We are given 3 vectors. The position vector of A written as A, which is 2, 4, minus 4. And then the vector B, is given to be 5, 2, 2. And then the vector C is equals to 11, lambda, and 14. Okay, let me check that they are correct first. 2, 4, minus 4, 5, 2, 2, 11, lambda, and 14. Right, this is question 3. Okay, question 3. What does question 3? Sorry, question 4. This is question 4. What does question 4 ask for? Firstly, it asks for a unit vector parallel to AB, right? So for part 1, you want a vector which is parallel to AB and its unit vector. We all have learned to find such a vector, we take the vector divided by its magnitude. Okay, what is the vector AB? How much is AB? AB is actually OB minus OA, right? The vector AB is actually OB minus OA. So the vector AB is 3, 3 minus 2, 6. Right, 3 minus 2, 6. Right, the vector AB is just 3 minus 2, 6. You want to divide by the magnitude of AB. How do you find the magnitude of AB? Square, 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 added together, and then you take the square root. Believe me, it'll be 7. Right, so this is the intended vector that you need for part 1. Just take the vector AB divided by its magnitude. Alright, I could write this answer as like this, 1 over 7. They're equivalent, we can write in this manner as well. They're the same. No difference. Okay. Let me check. Okay. So for part 2 of number 4, it asks for the vector OP, and you're told that there is a that your vector A and B, P is in between A and B, and P is maybe here, where this ratio is 2:1. Okay, this ratio is 2:1. Big small, so I'm writing bigger. Okay, maybe I should do it in a different color. 2:1. So the ratio is 2:1. So we have learned that if you have a vector OA and then a vector OB, to find the vector P in between and in a certain ratio, we can use so-called the ratio theorem. How do you find the vector OP using ratio theorem? Ratio theorem tells me that you take this ratio of 1 times OA, so it's just OA, plus this ratio of 2 times OB, and then you divide by the sum of these two numbers is 3. So this one is like standing in my way. Let me erase. I just cannot make up my mind where I should write it. I think I should change and write the ratio above this ratio of 2:1. Okay, and maybe my point P is quite funny. Keep changing. Right, P is here. Okay, P is here. Yeah, with a different color, you can see the contrast. Okay, this is how you should find the vector OP. Right. So what I'm going to do right now is I'm going to perform the arithmetic of OA plus twice OB. OA plus twice OB, I'm going to get 12. Okay, I'm going to write this as OA plus twice OB, so it's 2 plus 10 divided by 3. 2 plus 10 is 12 divided by 3 is 4. Then again, 4 plus 2 times 2 is 8. 8 over 3. Okay, let me write this in bigger. 8 over 3. And then minus 4 plus twice of 2, so it gives 0. So this is my vector OP. Right. Then in part 3, you are told that the points A, B, and C. In part 3, right, the A, B, and C are collinear. Collinear means they lie on the same straight line, right? A, B, and C lie on the same straight line. So the diagram would look like this. Okay, maybe I will actually erase the top because I want a space here. Okay, I'm going to erase the top here. This is easy. Right. Okay. Right. So if they are collinear, right, then A, B, and C are on the same straight line. So you got diagram that's like this. A, B, and C, they are on the same straight line. Okay, this is the meaning of collinear. Alright, so if 3 points are collinear, they look like this, collinear, lying on the same straight line. If that is the case, then the vector AB will become a multiple of the vector, say AC. Right? Okay. If three points are collinear, like in this case, A, B, and C, they are collinear. They're collinear, right? So AB is a multiple of AC. Of course, B need not be right in the center. Look center. I better change this before you think they have to be. So this is B. Alright. So the vector AB from here, right? 3 minus 2. 3 minus 2, 6 must be equals to a multiple of AC. AC is 9 lambda minus 4 and then 18. So judging from here, right, you will see that this number k has to be how much? Now look, okay, 3 must gives you k times 9 and 6 must give you k times 18. So that suggests to me that k has to be 1/3. Okay, k has to be 1/3. So if k is 1/3, then minus 2 is equal to 1/3 of lambda minus 4. And therefore, based on this, if k has to be, okay, let me borrow some space here. If k has to be equals to 1/3, that tells me that lambda would have to be equals to minus 6 plus 4, or equals to minus 2. And that is actually question 4. Do pause me if you have to in class. Just pause me if you have to ask questions. Next, we want to go into question 5. So I hope you're okay with number 4, right? If you have a question, as I do it, you want to just pause me, as in pause the video and tell me the questions that you have, right? Just feel free to interrupt. I'm going on to number 5. Okay, number 5. Okay, let's see what we have on number 5. For number 5, okay, question 5. M and N midpoints of OA and AB of A parallelogram. CM and CN cuts the diagonal. Okay. Okay, so OA and OC. So maybe let's draw a diagram. A, OA, B, C. I hope my diagram is good. This one looks not so good. I think this should be better. Okay, alright, roughly again. My drawing may not be that good. B, C. Alright. So you're given a diagram OABC. You're told that this is vector A and this is vector C, right? Vector C. Okay, let me mark this like that. Let me mark A is like that. Okay. Then this is vector C. Alright. And then in this diagram we are told there is a point M on OA and N on OB. So there is a point M, we are told is midway. This M, maybe I should write this again. And this N. Okay, so you want to remember that these 2 points M and N are midpoint, right, in the center of OA and the center of AB respectively. And then you are told about CM and CN. CM and CN. CM and CN, like that. Okay. And then they talk about the diagonal OB. This diagonal OB. Oops. Okay. So you're told that they meet at the point D and E. So this point D and this point E. Right? Okay, so this is how the diagram looks like. This is not very straight, okay? Maybe I should improve on this diagram a bit. It annoys me. The diagram is not too good. Okay. This E. Okay, let me touch up. Okay. Alright, okay. So first and foremost, you are asked to find the vector OD in terms of A and C. The vector OD in terms of A and C. Okay. Okay. For such a question, right? For such a question where you have to find this vector OD, and there's actually a crisscross like this. You have to actually do something like this. You want to introduce two ratios, right? Two ratios. You want to say that this point D divides this into ratio of, say, for example, lambda and 1 minus lambda, because you don't know at this point. All right. Then you also want to say that OD to B, right, is in the ratio of, say, mu and 1 minus mu. Okay. Let me say once more. We are saying that the ratio along this direction is lambda is to 1 minus lambda, and the ratio along this direction from here to here is mu is to 1 minus mu. And maybe I want to erase this and change the color, because too many red can get student confused. I'm going to write just this vector this vector as C, and this vector as A. Right, obviously it has to be C and A because O and OC. So now for such question, you want to try to actually introduce your own ratio. So with this, right, with this, I want to actually first and foremost find the vector OD. Find this vector OD, right? In the OD as part of OB. So I'm going to start off by saying that the vector OD is equals to a multiple of OB. Right? How do I get this number though? It's actually mu over the sum of mu and 1 minus mu of OB, or just mu of OB. Right? And then OB, look at the diagram, right? OB is equals to A plus C. Alright. On the other hand, this vector OD, right, as part of this triangle, this vector OD as part of the triangle, right, is equals to, using the ratio theorem, is equals to lambda of C plus, okay, let me pause and let's see if you can read my mind. What am I going to write next? I'm going to pause for a moment while I print the board for you to ponder. What am I going to write next over there? Okay, so if you understand what's going on, the next part is I'm going to take 1 minus lambda times this vector here. 1 minus lambda times this vector, which is half of A. And you're supposed to divide by what? You're supposed to divide by the sum of these two numbers, which is 1. So I'm going to just ignore it, okay? This 1, right? So again, okay, I found the vector OD using ratio theorem. This times this plus this times this. So now, once you reach this stage, you now have an expression of OD in terms of A and C, an expression OD also in terms of A and C. And because A and C are non-parallel, I can now simply compare the coefficient and say that mu of C and lambda of C will tell me that lambda and mu have to be equal, right? Mu of C and lambda of C. So what I can see is mu and lambda, they are equal. And what else? I can actually see from here that mu of A, this is 1 minus lambda of half. So I therefore can say that mu is equals to half of 1 minus lambda. Right? So by solving these two simultaneously, you could be able to obtain the result that mu is equals to 1/3. And of course, lambda is 1/3 as well. So from here, we therefore can say that OB in terms of A and C, OD will be equals to 1/3 of A plus C. Okay. Prove that the points D and E trisect OB. So what I was trying to say here is you want to now prove that you want to prove that this point and this point cut this 3 into these 2 points cut this entire line into 3 equal parts, 1 part, 2 parts, and 3 parts. And how would you do so? To do this, you want to now look at it this way. We want to try to actually find BE. Okay, I'm going to write the word similarly. Okay. Similarly, you want to find the vector BE. Okay, how are we going to find the vector BE quickly? You want to now see that this vector is actually minus A, and this vector is actually minus C. Can you see? So E is like D. Just that in the case of D, you have A and C on either side. But in the case of BE, you now have minus C and minus A on each side. So based on the same argument as you had earlier, I can conclude that BE, the vector B, right, is 1/3 of minus A minus C. By the same argument, by same working for OD. Right, you can go through the same process that what I did for OD, and therefore your conclusion is that EB okay, is 1/3 of A plus C. Right? Okay. EB in this direction, this is B, right? The opposite is EB. So therefore, based on the fact that OD is 1/3 of A plus C, and EB is also 1/3 of A plus C, you therefore can conclude that DE right, DE, the vector D, right, which is has to be also equals to maybe too fast. I'm gonna write this, okay? I'm gonna say this. Maybe write this, okay? OD plus DE plus EB is equals to A plus C, right? So that let you conclude that DE is also 1/3 of A plus C. Hence D and E trisects OB. Okay, this is question number 5.